Hi everyone, it's Jian here. In this video I'm gonna demonstrate how to start creating your first circuits on Tinkercad, as well as how to measure voltage and current in a simple circuit with an LED, a resistor, and a switch. This basic knowledge you can apply in all complex circuits that you're gonna encounter. Right, so this is my first video in English. I hope you enjoy it, and please give a like and subscribe to the channel if you like it. First of all, you're gonna open the circuit. It's gonna be a blank circuit, and then you can start bringing some components to your circuit. And then the easiest way to do that is come to this tab and search like breadboard. It's gonna pop up a lot of components. You pick the one you like it, and you just drag and drop to your circuit. If you look for an LED, you can search for LEDs, whatever. So in this case, I already selected a power supply, 10 volts, 2 amps. You can change the voltage here, the current that it will feed to the circuit. It's like pretty easy. I selected also a DMM for us to perform the measurement. And I have a slide switch that would turn on and off the circuit. LED that will indicates to me when the circuit is on, when the circuit is off, and a resistor that will limitate the current that will pass through the circuit, the current that will flow in the circuit and in the LED. If you turn on your circuit, by this limit switch without a resistor, you're gonna burn your LED, and you don't want that, right? So always remember, every time you turn on an LED, you need to put in series with a resistor, and that will limit the current that will flow through the circuit and will not burn your LED. So in the breadboard, this rail here, it's all short circuit, so it's all connected, as well as this one in the horizontal direction. But these ones, they are in the vertical direction. So keep that in mind. Okay, I'm gonna bring a positive from my power supply and a negative from my power supply. Right? You can change the color of the wire here, and that will allow you to follow your circuit more easily and also keep track of your circuit. Right? Okay, then from the power supply to my switch, I'm gonna put the voltage here, and then when I flip my switch to this direction, the voltage will come to this terminals here. So I'm gonna put my resistor here. It's connected to this leg, right? And then we have our LED, right? So LED has two terminals, the cathode and the anode. Always remember the cathode is this flat side. You see here it's a bit rounded, here it's flat. So the cathode is the flat side, and the flat side needs to be connected to the ground, right? So we're gonna connect it to the ground. So let's just simulate the circuit and see if it's working. Okay, right now our switch is off, so our LED is off. If we flip the switch, the circuit will be on and our LED will be on, right? So the LEDs, they can stand a certain amount of current, and I will demonstrate exactly how to measure with the DMM, but we can, in this application, it's just a simulation, we can monitor the current that is flowing through this simple circuit, and it's 16.9. That's because my resistor has enough resistance to limit that current to that value. Let's see, if you change your resistance here to, let's say, 100 ohms, you're gonna see that the current will go like pretty high for the LED, and you're gonna have an indicator here, a warning. If you click on this indicator, it will say to you, current through the LED is 75.3, and the maximum recommended is only 20 milliamps, right? So you don't want to damage your LED, right? So you're just gonna click on the resistor again and start. If you don't know exactly how to calculate, just start typing numbers and see the changes in the circuit. So you're gonna find the best resistance for that circuit. In my case, we have 470, so it's a good resistance. It's a commercial value you're gonna find it, and it's okay, it works, right? Okay, so I'm gonna turn it off. Okay, so now I will stop the simulation for a bit, and then I will connect my DMM to show you how to measure current and voltage in the circuit. So current needs to be measured in series, and voltage needs to be measured in parallel. So let's start with voltage. All right, let's connect our negative leg of our DMM to the negative, to the ground of our power supply, or the red lead of our DMM to the anode of the LED, because we want to measure the voltage across the LED. So how many volts the LED is dropping in the circuit. Okay, I'm gonna just make this leg red just to make it easy for us to understand. So start simulation, and we see that the voltage across the LED is 2.05. So that means that the remaining voltage, which is around 7.95 volts, is being dropped in the resistor. So let's just check if our estimation about the voltage drop across the resistor is correct. Okay, I'm gonna stop the circuit. And this time I'm gonna connect it across the resistor. I want to see the difference of voltage between this point and this point. Okay, and yeah, boom, 7.95. So we were correct estimating that the resistor is dropping most of the voltage in the circuit. Okay, so what that means is that your circuit might not need a 10-volt power supply to turn on a resistor, right? Because that might be too much. You could maybe use 5 volts. So it's up to you. But remember, if you change the voltage, let's say 5, you also need to change the resistor, right? So in order to achieve the same bright in your LED, right? Okay, so just keep that in mind. I will return to the previous values, and I will show you how to measure current in the circuit. As I explained, current is a bit different because you need to measure in series with your circuit, right? I'm gonna delete this. I'm gonna just reorganize the circuit. It's the same, it will be like connected in the same way. Okay, I'm just gonna add one of the legs here and here. So what that means is I broke the circuit, and now I am kind of forcing the current to flow through the DMM and then go to the LED, because that's how you read current. The current needs to pass through the DMM, and that's why you need to be in series with your circuit. Okay, so start the simulation, and I'll select voltage here. Okay, so as you can see, the voltage that my DMM is reading is exactly the same as my power supply is showing. But remember, most of the times you do not have this reading here. You only have your DMM, and then you need to connect your DMM to the circuit in series, and then you get the reading in that specific branch, right? If you have multiple branches, then it's a more complex circuit that I can create another videos to show everyone. But by now, the simple circuit, this is how we measure the current. And it doesn't matter where we are measuring the current, because we can measure the current, let me say, we can measure the current in any point of the circuit. If we want to measure the current here, see, we're not using any part of the circuit, we're just using the ground and the cathode of the LED. So the current is the same. The current that is flowing through this wire, it will be all the same here, 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 or here. It doesn't matter. So let's just confirm it, and boom, we have the same reading. Okay, so all right, so I hope this video was helpful for people that are starting to create some circuits here in Tinkercad. We have a wide range of devices that we can use it, and I hope this helps you. And please hit the like button and drop me a comment if you found this video useful.